Good day, everyone. I am Mom Princess, and welcome to another day of our discussion on the topic about electronic configuration, orbital diagram, and valence electron. In this video, I want to tell you how you will calculate electronic configuration and valence electron, but I want you to understand this one carefully. Let us have first the definition of electron configuration as it describes how the electrons are distributed in the various atomic orbitals. Take a look at the example of the hydrogen here for its ground state electron configuration of 1s1. And there are two ways on how you're going to write electron configurations, such as SPDF notation, wherein there is a value of energy level, sublevel, and number of electrons. And then for the orbital box notation, if you watch my video a while ago or yesterday, you can have the idea about this orbital box notation, wherein you use the arrows to show the electron spin of either or in between positive 1/2 for the arrow up and negative 1/2 for the arrow moving downward. So let us start having our example for the element of nitrogen. So nitrogen has an atomic number of 7 and atomic mass of 14.007. So from the atomic number, which is 7, therefore it has 7 protons and 7 electrons. And atoms, as we all know, are electrically neutral. But we will be focusing here on 7 electrons since we are dealing with electron configurations. So here it is. Here it's the easiest step that we can have for the electron configuration. 1s1, 2s1, 2p. So 3s, 3p, 3d. So let me explain to you this one. On the first energy sub level, you have only one s. For the second energy level, you have 2 sub-energy levels such as 2s and 2p. For the third energy level, you have the 3 sub-levels such as 3s, 3p, and 3d. And there are also 4s, 4d, and 4p and 4d. So the s sub-level, as we all know, can hold only 2 electrons. For the p sub-levels can hold up to maximum of 6 electrons. D has the maximum of 10 electrons and F has a maximum of 14 electrons. So let's start. So since you need 7 here for the electron configuration, so you can use 1s2. So 1s2. Since you need 7, you still need 5. So you need to use the next level. We have 2s2, so you have 4. So 3 more, 1s2, 2s2. Then the next level is 2p. So you cannot reach the 3s here because p has the maximum level of 6. So you can only use 2p, 3. So 2 plus 2, 4 plus 3, 7. So 1s2, 2s2, 2p3 is actually the electronic configuration of nitrogen. As easy as that. See? It's easy, right? So let us have another example. Element aluminum with the symbol of Al. Therefore, from the atomic number 13, the proton is 13 and the electron is 13. But we are focusing on the number of electron, which is 13. Using the sublevel, we have 1s, 2s, 2p, 3s, 3p, 3d. But you can also add, if you want, 4s, 4p, 4d, 4f. You can actually use more than until 7 because of the other elements having greater value of atomic number. So we have here 1s, 2s2, 3s, and 4s. So it has a maximum of 2 electrons. For p, we have 6. For d, we have 10. And for f, we have 14. So since we need 13, you can use already 1s2. So next is 2s2. So take a look at the exponent here. 2, 2, we have 4. So next we have 2p. So 2p6. So you need to check again. 2 plus 2, 4 plus 6, 10. You still need 3 more. But 3s has a maximum level of 2 electrons. So it will only be 3s2. So 2 plus 2, 4 plus 6, 10 plus 2, 12. So last, we have 3p with a maximum of 6, but you can only use 1. So 3p1. So 1s2, 2s2, 2p6, 3s2, 3p1 is actually the electron configuration for aluminum. So we're done with it. With the second example, let us have another example. But this time, you're going to have the orbital diagram and valence electrons. Since you already have the idea on how you're going to do the electron configuration, based on the electron configuration example of nitrogen, the one that we solved a while ago, which is 1s2, 2s2, and 2p3, 2 plus 2, 4 plus 3 is 7. So that is the electron configuration. Now you can have this one and be used for the orbital diagram. So 1s2 has 1 box. For 2s2, we have 1 orbital or 1 box, and 2p3 it is 3. Because in 1 box, it's equivalent to 2 arrows or 2 electrons. Okay? So P has 6, so it has 3 boxes. For D has 5 orbitals or 5 boxes. And then for F, it has 14, so it has 7 orbitals or 7 boxes. And so let us have now the use of the arrows here. So 1s2, we need to complete 7. So I told you before that you should finish first all the arrow moving upward. So 1, 2, 3, 4, 5. Go back to the first box. 6 going downward, and then 7. So there you have it. That's the orbital diagram for the element nitrogen. Now let us have the valence electrons or valence diagram. So you need to use the shell. So this is the first shell, wherein the maximum level of this is 2. Okay? So you can have here 1, 2. Since nitrogen needs 7, you still need 5 more electrons. So second shell, the second shell needs maximum of 8, but you only need 5. So 2 plus 5 is 7. So meaning to say that in your outermost shell, the one at the outside, that's why it's outermost, you have 5 electrons or valence electrons. For your innermost shell, the one at the core, the one at the center, you have 2 core electrons. Therefore, if you add it, 5 electrons plus 2 electrons, you have 7 electrons. And that's how you're going to do with your valence diagram. So it's very, very easy. Okay? Let us have another example for the element aluminum. Orbital diagram for the aluminum using the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p1. So using the orbitals, we have 1 box for 1s2, 2s2, 1 box, 2p6 we have 3, 3s2 we have 1, and 3p1 we need 3 because it has the maximum levels of 6 electrons. Now we need to have the arrow. So you need 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's the orbital diagram for the element aluminum. Now for the valence diagram, we have here the core shell or the innermost shell. Aluminum, for the innermost shell, it can only hold up to 2 electrons. So we have 1, 2. For the second shell, it can hold 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 2 plus 8, 10. You still need 3 more. So next shell, it can hold another electron, so you still need more 3. 1, 2, 3. So there you have it. You completed already. You have 13 electrons. Therefore, you have 3 electrons at the outermost shell. Since you have 2 core here, you need to add 2 plus 8. So you have 10 electrons for the core electrons, or the one at the inside the outermost shell. And you need to add it, 3 plus 10. So therefore, you have 13 electrons. See, it's easy, right? Now it's your turn to solve for the electron configuration as well as the orbital diagram and valence diagram. Let us have now the element carbon. I'm giving you only 1 minute to solve for this. So let us check. So carbon has proton 6, electron is 6. So we focus on the electron. So 1s, 2s, 2p, 3s, 3p, 3d. S level can only hold up to 2 electrons, 2p, 6 electrons, and 3d, 10 electrons. So you need 6, so you can have 1s2, 2s2, 2p, 2, not 6, because if you use 6, you are exceeding to the number of electrons, which is only 6. So 2 plus 2 plus 2 is 6. So therefore, this is the electron configuration for carbon. Okay, next one. We're going to have the orbital diagram here and the valence diagram. Again, 1 minute. Okay, let's check. For the orbital diagram, based on the electron configuration, we have 1s2, 2s2, and 2p2. And therefore, you can have 1 box for 1s2, 1 box for 2s2, and 3 boxes for 2p2. So you can have now the arrow. So 1, 2, 3, 4, 5. Go back, downward, 6. So that's the orbital diagram for carbon. Now for the valence diagram, we have here, carbon. We have 2 at the core or at the center. And then another level or shell. We have here 3, 4, 5, 6. So there you have it. We have now the valence diagram for carbon. And for your valence electrons at the outermost shells, you have 4. For the core electrons, you have 2. So 4 plus 2, you have 6 electrons. So we're done. Thank you everyone for listening. See you again on my next video. Keep you updated. You may subscribe to my YouTube channel, Mom PM is the key, and click the bell button. Thank you for listening. Goodbye.